I want to talk today about how agents are essentially changing everything. They're changing how we're interacting with code generation. They're changing how we're booking travel. And we think they're also changing how you're going to interact with databases from now on. And I want to show this with three specific examples. One is querying, which is maybe the easiest one to reason about when you read data from your database. But I also want to talk about writing data, which may not be so obvious of how and why you would use agents for that. And then last but not least, also about the personalized database. So can we use agents to somehow give users different experience based on their preferences? Let's start with querying, which I think for me is the easiest one to reason about. And I want to start with a very quick walkthrough of specific query interfaces for databases. So I'm pretty sure everyone in this room has seen a SQL query before. And have this example here. We're just retrieving users from our database that have signed up in the past 7 days. And SQL's been around for over 50 years. It does require a very precise syntax, not just because it's string-based, but also because you have to know the underlying schema, right? So you have to know two things. One is the structure of SQL itself, but also your underlying database, your table, what the underlying types are, et cetera. And then, of course, because it's string-based, everyone knows Bobby tables, like the classical example for SQL injection. There's also a bit of a risk involved with it. And for me, this is sort of like the first stage of database query interfaces. Then in the next stage, this is in this example that I have here on this slide, is I think taken from MongoDB, and it's in JavaScript, where we have these native drivers and ORMs, where essentially we're saying we don't want to put strings together anymore, but we want to use code. Can we use code to represent exactly the same thing? And in this case, it's again users who signed up in the past 7 days, but we have a massively improved UX because now you're writing code and you're writing the database query as code as well. And then of course it also mitigates that risk of SQL injection because it's just code. There are other ways you don't necessarily need to use one of those native drivers or an ORM just to mitigate the risk of SQL injections, but it comes with it. And now we're going to do sort of the first big jump to RAG. And what you're going to see is I also had to change my example because this example query that I had of all the users that signed up in the past 7 days, that doesn't work with RAG anymore because what you do with RAG, and I'm going to say a bit more about RAG in a second, but essentially you just take this entire input query, create a vector embedding, or you can also use, doesn't necessarily have to be a vector embedding, but that's the common way, and then you do a similarity search based on that query. But unless there's like one object in your database already that lists the users that signed up, there's no way to retrieve that kind of information. So we have that complete shift from structured to unstructured, but now we're kind of losing the best parts. Like we're gaining a lot, but we're also losing the best parts of structured queries. So next is the era of agents. So this is kind of the ideal state. We want to have this RAG-like interface where we just say like, hey, list all the users that signed up in the past 7 days, and then we get this RAG-like response back, but it actually ran the query with the structured information and maybe did some aggregation and lists the results as we expect them. And this is pretty much possible right now, as you'll see in a second, with Weaviate. But I first want to give you a quick intro of what Weaviate even is, so you know how to place it in that context. Weaviate started as a vector database. I feel like today with agentic stuff that's happening, it's much more than just a vector database, but this is kind of the core roots where we would say we would place all the objects in the database into this multi-dimensional space. And in this example here, you see some fashion example from an e-commerce platform. And on the one side, we have these skirts that are all blue, and they have this like wavy ocean pattern on it, and they're all close by. They represent one specific cluster in that vector data space. And then there's another cluster where the colors are different. They're like more lighter, more brighter, tan and white, and so on. But also what you can see in this example is multiple modalities. So in that same cluster, we have all those images of blue skirts. We also have a text snippet, and that text snippet can basically, as a human, you can immediately tell it's describing what we can see on those pictures. And that's a key characteristic of the vector space. The vector space is not specific to one modality, but it can work across all modalities. Then the next sort of wave of use cases came with retrieval augmented generation, which got really big when the first LLMs came out. And if you remember the first generation of LLMs, they were not as good as today's generation. They hallucinated a lot. And the first kind of remedy for the hallucination was essentially, if the model doesn't know something, let's just inject it into the context somehow. And to find what you want to inject, you need to retrieve it from somewhere. That's the R in retrieval augmented generation. And technically, you don't need a vector database. You can retrieve with anything. But it was a very, very natural fit, because you could just take this entire prompt, create a vector embedding from that prompt, and do a similarity search on your vector database. And it would find the top 20 or 50 or 100 most relevant objects, which it could then reason about. And it would do that, or by doing that sort of at runtime, at query time, all of a sudden your LLM became mutable too, because you didn't have to retrain it if a new object appeared or went away. You could just use the normal database CRUD functionality basically to update it, which is pretty cool. And let me go here. And this is kind of what a Weaviate interface would look like before agents were there. And this is an example that I have here in the slides. This is our Python client, which is all handcrafted, which I feel like is something that you need to stress these days. It's not just because it was created before vibe coding was a thing, but also a lot of love and a lot of thought went into creating like a purpose-built API to really make the user experience as great as possible. And that's something that we also try to keep throughout the agentic age. Okay, coming back to the main point of this talk, the first of the 3 Weaviate agents, and in this case, the query agent, and I want to run you through this using an example. I built this database of various flights, basically an itinerary. I just asked an LLM, just create this example itinerary for me, and put all the flights in there, and various sort of guidelines of what they would be about. And now the first thing that I'm doing, very, very simple query, but one that would already break with RAG, is I'm just asking my query agent, how many flights are there? And I'm getting the response, there's a total of 18 flights scheduled. And this is while super simple, this is something that regular RAG simply could not do, because what would happen in a RAG world is we'd create an embedding for that query, and then we'd try to find the closest object. But there are only 18 objects in my database, and I want the fact that there are 18. That's the kind of information that I want to retrieve. And you can see under the hood, it ran an aggregation query, which is a query capability of Weaviate. And it didn't even use a vector search or anything, because that's not what the user asked for. In this case, the user just asked, how many flights are there? And we got a response. We can then take that same example and make it arbitrarily more complex. So for example, here we're adding a group by query. So we're saying, count the number of flights by airline. And then again, we're getting a response back where it says number of flights by airline are as follows. Lufthansa has 8 flights, United has 6 flights, KLM has 2, and both American and ANA have 1 flight each. So we got this really structured answer from the database in a RAG style query. Third example, and this is the one that I like the most because we can get kind of some domain understanding in that one. I asked it, will I be able to use TSA PreCheck on all my flights departing from the US? And those of you who travel a lot know that both TSA Pre and Global Entry can be a lifesaver because you don't have to take off your shoes anymore. You don't have to stand in line to go through security a lot. But in my data set, there is no field in the schema or anything that says, is TSA PreCheck available? But what the query agent did in this case is, because it looks at the schema and it has access to your schema at runtime, it found out that there is a field called known traveler number provided, and it made the connection that to be able to use TSA PreCheck, you need that known traveler number. So it says like, hey, yeah, you have that number provided, and here are the 7 flights departing from the US that all have the known traveler number provided. Therefore, you can use a TSA Pre. Speaking of domain knowledge and adapting to specific domains, how can we do that? Here is an example of a query that failed, and I'm going to tell you in a second why it failed. I told it to list all the flights that depart from Germany. And what the query agent did in this case is say, okay, that makes sense. I see there is a field called origin country. I'm just going to set the filter to equal to Germany, which is exactly what the user just asked for. Interestingly, this failed. Why did this fail? Because this is what my data looks like. And if I'm looking at origin country, it says DE. This is a flight from Frankfurt in Germany, but the country is specified as this 2-letter code, and the agent didn't actually know that. And this is a real failure, by the way. When I built this first data set, I actually ran into this, and I was like, hey, this is so cool. I can use this because we can actually fix this. And how do we fix this? There's this field that's been in the Weaviate schema for probably 5 or 6 years, and it never really had a real use, but now it does, which is the description of a specific property in the schema. And we're now injecting that into the system prompt, and we're telling the LLM what the schema is like. So I just filled this prop that was already there, but was completely unused. I just filled this with, hey, this particular field is specified as the ISO 3166 alpha 2 whatever country code, which essentially means this is the 2-letter country code. And that was all that's needed. Then the query agent, now if I ask it the same thing again, hey, list all the flights that depart from Germany, it now understands this. It now gained this domain knowledge of, okay, the country is specified as a 2-letter code. So when I get a country, I need to put this in the right field, and all of a sudden here are 7 flights leaving from Frankfurt, Germany. So in general, this is a pretty easy example, of course, and we're kind of limited by the domain understanding of the common LLMs that are used in this case. And of course, they get better all the time. There's new versions coming out all of the time, and they're better and better at various tasks. But some domains are just not public knowledge, right? They're trained basically on public knowledge that's out there. But if you at your enterprise company have some specific domain knowledge that's not in there, they might struggle with this. And what we can do is, the simplest example, and this works for a surprising amount of cases, is really just this injecting this into the prompt, into the system prompt. And you can do this per prop, as we just seen with the previous example. Or you could also specify a global system prompt to just tell the agent, hey, you are a flight booking agent. These are the kind of general rules or so that you can use when the user asks you something. For the cases where that's not enough anymore, what we're considering is, in the future, if you already have an LLM that you've trained on your own data, why not just use this for the query agent? Why not just pass that on to us, basically, so we can use it in the query agent? Or, and this is kind of like my favorite vision, since we're a database company and we store all your data, could you just give us permission to train a model on that data that's in the database, and all you have to do is click a button, we fine-tune that model for you, and we try to reason about this in the data that's already available, so we can then create a better query agent. So the current use cases at this point, and we released this agent just 4 or 5 weeks ago, so there are not too many use cases yet, and we haven't even checked if we have logo rights for anyone, so we haven't listed customers, but just some use cases that we've seen so far in the legal domain. Of course, conversational AI, customer support, customer experience, media and content, all of those. What's kind of limited about the query agent right now, other than the main stuff we just talked about, right now it does not have support for memory yet. So memory was just added to ChatGPT, was very visible on social media. It does not do that yet. And another thing that we want to build in the future is this kind of self-reflection, where you could argue the whole journey that we just did about finding out that the data doesn't actually match that field, and we needed to give it this hint for that data field. You could argue this is an agent. It should just figure this out on its own, right? So we want this kind of loop of trial and error and reflecting on the results and adopting from there on, which is another future topic. Under the hood, and I'm really sort of highlighting this for the scaling part, because we're going to see in a second, like one of the other agents scales very differently. There's 3 LLM calls, 3 different LLMs for understanding the query, building the Weaviate queries. That's basically the first LLM needs to be really good at extracting whatever it is that the user is saying. The second LLM needs to be an expert at the Weaviate APIs, plus it's got that runtime injection of your specific schema. And then the third one, very important, is an eval agent. So we need to evaluate if the results are any good or if we need to do something else. What's nice about all of this is that this load is fairly predictable, because for a single query, we're doing 3 LLM calls. So you can model what are your queries like per day, do they go up and down, and you can scale within certain boundaries relatively easily. And I'm stressing this because there's another case right now where that's absolutely not the case. And yeah, this runs as a multi-tenant service, by the way, which helps us sort of pool incoming requests and reuse the resources. But we could also run this inside of a customer's VPC, for example, if you don't want your data to ever leave that VPC, because Weaviate itself can also be deployed in VPC. So we also have that on the roadmap for the query agent itself. For observability, and especially also for the eval step, we're using Pydantic AI under the hood. So shout out to the folks from Pydantic AI. We also have an expo booth down on the ground floor. And this really helps us just in rapid prototyping, because of course stuff changes all the time, and this is one of the fastest moving parts in Weaviate, and Weaviate is a database company, so it's in the AI space, so yes, it's moving relatively fast, but the core database still moves orders of magnitude slower than all the agent stuff, where basically everything changes all the time. And it helps us, especially with evals, to just take that boilerplate away, and yeah, also getting stuff into Logfire. For example, when these error cascades happen, if one LLM call does not provide a perfect answer and then it's piped into the next, and you got this like compounding effect, that's very great to debug with Pydantic AI. Okay, that was the first of 3 agents. The next one is for writing data. And this one, you could ask yourself the question, if we can just inject stuff into the prompt at runtime, at query time, why would we ever need an agent to write data? And there are many use cases, but these are kind of my 2 favorite ones. One is we could just pre-calculate something to make it cheaper. So let's say you're serving an e-commerce platform in multiple languages, and you have descriptions that need to be translated into multiple languages. Option 1 is you could translate it at query time. But if you have one object that's sort of on the hot path and constantly being queried, why would you retranslate it over and over again? It would just be way cheaper if you just translate it once, write it back into the database, and don't have to like mess around with third-party caches or anything. It can just be written back into the database, and then the next time you serve it. And that's kind of a transformation that we think that can happen in an agentic way. And then the other one is about making data more accessible, especially for aggregation queries. So for example, if you run a classification or a labeling task, it's relatively complex from an LLM perspective to figure out what the right label is, but once the label's been assigned, it's just a string. So you can do arbitrary aggregations with that label once it's there. So it's again sort of a cost thing where you can do some work up front and then at runtime have very efficient and fast queries. So I'm using my flight example data set again as an example here. And let's say our goal is to get statistics about international flights versus domestic flights versus Schengen flights. So Schengen flights are within the EU, basically international flights within the EU that behave as if they were domestic flights and no passport controls, et cetera. And if we're looking at the objects that we have in our database here, there is actually no field for is it international, is it Schengen, whatever. But what we do have is the origin country and the destination country. But there's like this one jump involved, especially to figure out if this is a Schengen flight or not. We can't just compare is input and output equal. We need something more than that. And for this, we can just use the Weaviate transformation agent, which is our second database agent that we just launched, which helps you transform your object that you already have in your database. And you can see 2 example transformations. We're just telling the agent, please add 2 new properties to these existing objects. One is, they're both Boolean properties, and one is just, is it an international flight? And the other one is it a Schengen flight? And then all we're doing at the bottom is just kick this off, run it in the background, and come back when the task is done. And this is, again, sort of something that's very, very agentic. And because my example data set is just 18 flights, that was pretty much instant. Of course, you could do this on billion scale data sets as well. But when I got back here, and this example is a flight from SFO to New York, so this is all a domestic flight within the US, so it's not an international flight, and it's also not a Schengen flight. But we do have this property now, and now comes my favorite part of the entire talk, because now we can loop that back into the other agent, and now we can query about it. So here's taking that same result that we just modified with the transformation agent and piping it back into the query agent and saying, hey, what is the ratio and count of international flights, which would have been very hard to aggregate before. Now it's super easy, it's trivial, because there's now a field, is it international? And it's telling me approximately 55.56%, which sounds very precise for 10 out of 18 flights. But that's, imagine doing that on billion scale data. So this is pretty cool to just sort of run this transformation once, and now you can aggregate it pretty efficiently again. There are cases, though, where such a transformation, or where transformations in general, could maybe confuse the large language model a bit. And one example here is if it's very much rule-based or maybe even algorithmic. So everyone knows if you give your LLM specific hard rules to follow, sometimes they do follow them, and sometimes they don't. And if you run this on a billion objects and you have a 5 to 10% failure rate, then that means you might have 50 million to 100 million objects where the transformation was actually wrong. So that's maybe not ideal. Another aspect is simply the cost. If it can be done with a rule, would you really want one LLM call per object if it can be rule-based? So what we're considering here is, can we use the transformation agent and the LLM that's part of the transformation agent, can we use it just once to figure out in the beginning what is that rule that should be applied here? And could we then apply that rule or that transformation algorithmically? Like a regular expression takes, I don't know how many CPU cycles, but a lot fewer than an LLM call takes GPU cycles. So that's kind of one of the future considerations of, could we make this even for good old boring algorithmic transformations, but you want to be able to kick them off with a single prompt as well. Under the hood, and this is the scaling part that I talked about before, right now we're making one LLM call per object transformed. And this makes a ton of sense for translations or summarizations, of course, because you need that logic, but maybe not for all cases. So we just saw it with the algorithmic cases. But from a backend scaling perspective and the load, this is very, very unpredictable, because the user could have a billion data objects stored in their database, never run a single transformation ever, and right now they could just kick one off with a single prompt, and essentially leading to billions of LLM calls. And this for us was the part where we said, like, we don't want to run that infrastructure. There's other companies out there that can do that way better, and in this case, in our case, we're relying on Modal. So shout out to Modal. I know that Charles Fry from Modal is also here at the conference. And this is really great for us because we don't have to worry about massive surges, massive bursts of GPU calls, because they'll handle that for us. And based on the pricing model, well, we only pay basically when we use it. And that's of course much better than having tens or hundreds of very large GPUs just sitting around. The third and last agent that I want to talk about is the personalization agent, where our question is, can we give a personalized experience to every user of the database? And here, there's also like a fair question could also be, is this really an agent? Is this really an agentic workflow? Or are you just describing a recommender system? And the reason that we think this is an agent is because we have this reasoning ability about it. Like the LLM can explain, and you'll see that in a second on an example, it can explain why a certain decision was made to serve some objects to one user and maybe not to another. And in general, it just learns from user behavior. And what's also important for us is it's, again, this sort of zero setup, and that I didn't mention this for the previous two agents, but the idea is you already have data in your database, and now you can just run that agent. Like, no setup required, no nothing. Just use it on the data that you already have, and that's the same. That's true for the personalization agent as well, because it allows you to just all of a sudden serve personalized apps, user-specific experiences, and also just prototype very, very quickly. Here's a very simple example of what that would look like. So here we have a simple data set with recipes, and we have a persona that represents a specific user. And in this case, they like specific food, they like specific cuisines, Italian, Thai, chocolate, etc. But they don't like mushrooms. And then you can also see that we can store various interactions, just, for example, clicking a like button here and there, or something that we could just observe and store this as either a positive or a negative interaction. And all of that can then be used to give personal recommendations with some sort of a rationale where the agent essentially said, in this case, it's not just the recommended recipes, which is the list at the bottom, but it's also saying, hey, because you love Italian dishes and you've shown interest in different cuisines, we've prioritized dishes with Italian, Japanese, and Indian labels reflecting your preferences, blah, 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 blah. We avoided items with mushroom content because that's what you specified you don't like. And we think that's pretty cool because you can just do this out of the box with all the data that you already have in your database. Okay, so quickly recapping, we think that agents are changing the way that you interact with pretty much anything, whether that's code generation, whether that's ordering stuff, booking stuff, and we think that also applies to databases. Structured queries or structured query languages are not going to go away. They definitely have their purpose, but we do think to really be, and we're using that term AI native a lot, to really be an AI native database, we think you need to be able to interact with your database using just a single prompt. And as we've shown in our example, you can do that to retrieve data, but you can also do it to transform data using the transformation agent, and then you can also get personalized results with the LLM re-ranking factor. So what's next? If you want, there are two QR codes that you can scan if you like. One is a live event, but it's an online event that you can join where we just walk you through all kinds of agent-specific things, all three agents, to really get to know them better. And the other link is just to our documentation. It's basically just the documentation landing page where all three agents are explained, usage examples, etc. Cool, that's it for me. If you like, you can look up Weaviate, you can star us on GitHub, you can add me on LinkedIn, you can also follow me on Twitter or X, where I post about all things database, AI, a lot of vibe coding lately because I've started this experiment on vibe coding a production-grade database from scratch, and that happens to be a domain that I know something off, so it's kind of a fun experiment. So if you're interested in that, please do give me a follow.